Well, we have a profoundly important announcement to make, which is the most epic chip-building exercise in history by far. We aspire to be a galactic civilization. So I think the future that everyone, well, most people, I think, would agree is the most exciting is one where we are out there among the stars, where we are not forever confined to one planet, that we become a multi-planet species, like the best science fiction that you've ever read. You know, there was a physicist, I think he was Russian, in the 60s, Kardashev. He thought about, at a high level, how would you consider any given civilization? And he said, well, if you're type 1, you're using most of the energy of your planet. And we actually still have quite a ways to go to be properly a type 1. We're still using a tiny fraction of the sun's energy that reaches our planet. So the way to actually scale civilization is to scale power in space. This is necessarily true because we actually capture such a tiny amount of the sun's energy on Earth because we're just this tiny dust mote. Yeah, we want to be a civilization that expands to the galaxy with spaceships that anyone can go anywhere they want at any time and have a city on the moon, cities on Mars, populate the solar system, and send spaceships to other star systems. So to do that, we need to harness the power of the sun. And so a terafab, while it is enormous, a terawatt of compute per year is enormous by our sort of civilizational standards. It is still just one step along the way of being even a Kardashev. You still have a long way to go to even be a Kardashev 2 level civilization, and you're not even registering as a Kardashev 3. It really requires a combination of efforts of SpaceX, XAI, and Tesla working together to create this epic Terafab project. And you know, Tesla and XAI and SpaceX have all done amazing things that people did not think would be done before. So there's the Giga Texas fab here. There's the Optimus robot that's being built. There's a global supercharging network. There's really quite a lot. And it wasn't that long ago when people thought electric cars wouldn't amount to anything. And there were basically no electric cars for sale when Tesla started. And people said it was impossible, and now Tesla's making 2 million electric cars a year. Yeah. And then XAI, although it's a new company, now part of SpaceX, has also built the first gigawatt-scale compute cluster, which in record time. Jensen Huang from NVIDIA said he'd never seen anything built so fast in his life before. So a great compliment from NVIDIA. And then SpaceX, well, I guess you can read it for yourself. Well, you already know. I mean, the reusable rockets, people said that reusable rockets weren't possible, and even if you did do them, they wouldn't be economically feasible. So we did them, and then we made them economically feasible. And now we've landed over 500 times. And then we did the Falcon Heavy, and now we're doing Starship. And Starship is a critical piece of the puzzle because in order to scale compute and scale power, you have to go to space, which means that you need massive payload to space. And Starship will enable that. So in order to get to the terawatt of compute per year, you need about 10 million tons to orbit per year, and at 100 kilowatts per ton. So, but we're confident this is feasible. Like no new physics or impossible things are required to get there. So I'm confident actually that SpaceX will get to 10 million tons to orbit per year. To give you a sense of what we're talking about, the current output of AI compute is roughly 20 gigawatts per year. This chart explains why we need to build the Terafab. Because all of the rest of the output from Earth is about 2% of what we need. And we're starting off with an advanced technology fab here in Austin. So in the advanced technology fab, we will have all of the equipment necessary to make a chip of any kind, logical memory, and we will also have all of the equipment necessary to make the lithography masks. So in a single building, we can create a lithography mask, make the chip, test the chip, make another mask, and have an incredibly fast recursive loop for improving the chip design. So broadly speaking, we expect to make two kinds of chips. One will be optimized for edge inference. So that'll be used primarily in Optimus and in the cars, but especially in Optimus, because I expect the robots, humanoid robots, to be made 10 to 100 times more than the volume of cars. So, you know, if vehicle production on Earth is about 100 million vehicles a year, and I expect humanoid robot production to be somewhere between 1 billion and 10 billion units a year. Space has this advantage that it's always sunny. It's very nice. I actually think that the cost of AI and deploying AI in space will drop below the cost of terrestrial AI much sooner than most people expect. I think it may be only 2 or 3 years before it is actually lower cost to send AI chips to space than it is on the ground. Because in space, you don't need much in the way of batteries, because of it's always sunny. And the solar power, you're going to get at least 5 or more times the solar power you get in space versus the ground, because you don't have atmospheric attenuation or a day-night cycle or seasonality. You know, how do you get to a petawatt? Is the obvious next question. And you get there by having an electromagnetic mass driver on the moon with robots, with Optimi, and obviously lots of humans. And with that, you can send a petawatt. You can create a petawatt of compute and send that to deep space, and help us design incredible chips and make incredible chips and build a terawatt of chips, a terawatt of solar, and 10 million tons to orbit per year. Thank you.